All right, guys, welcome to your test review. I'm going to go over some of the questions from the practice test, the ones that you'll probably see on your test. If you're watching this, good on you. You have got a head start above everybody else. All right, before we start, I want to go over three ways to write an element and the atom, the three ways that we've seen. So, because there are three ways, I don't want you guys getting confused. So, one way that you'll see this is the typical elemental tile, the one that you'll see on your periodic table, where you just write, like we're just taking hydrogen, you write the atomic, sorry, that was bad. The atomic number goes at the very top. So you have 1, and then you have H, and then you have the mass, in this case 1.08. This is one way to write it. You have the second way that you'll see it in the kind of what we call the isotope form. So it's just the symbol H, and then now it's reverted. So now the 1.08 goes at the top. I'll do helium, so you can kind of see the difference. Helium has a mass of 4 and an atomic number of 2. So I'm going to write the 4 now goes at the top. The atomic number, which is the proton number, goes at the bottom, and this is helium, right? If I would have done this for the elemental tile version, it would have been He, 4 at the bottom, atomic number 2. So these numbers are flipped. And then the last version you'll see is when it says helium, and then it'll say the mass number. Okay, this is only the mass number. Notice that the atomic number of 2 is nowhere to be found here. So here I'd have to look at my periodic table and figure out that my atomic number is 2. Okay, so just make sure you know that there's 3 different ways to write all this stuff down. Okay, with that, we're going to move forward to some of the questions that you'll see on the practice test, starting with question number 4. Which part of Dalton's theory is what we know today as the law of conservation of mass? So that's something that you are going to see on your test, and you'll find this in your notes. So write John Dalton, law of conservation of mass, where matter cannot be created or destroyed during a chemical reaction. And that's true. Think of fire burning a wooden log. The wood gets turned to ash, but you have the same amount of wood that you started in the beginning as you do at the end if you're adding everything up, including the smoke. So think of a log, you burn it so it turns into ash plus smoke. If this is 100 grams, this plus the smoke, all in all, is going to be equal to 100 grams. That's what that law is saying. Whatever you have at the beginning, which we did last time, we have at the very end, right? That's not a new topic, right? The other thing that we have is question number 5, where it's asking what 2 part of Dalton's theories are not completely correct. Make sure you go back and you look over these. So, if we're looking at your notes again, John Dalton, he was able to support it. He talks about 5 things. But it says, John Dalton's theory had 2 flaws. Point number 2, this is not completely true, where all atoms of one element are identical. We know that, right? Because you can have multiple versions of the same element, and we call those isotopes, where it's just the same number of protons but different number of neutrons. So not everything is the same. If you find hydrogen, you're not necessarily finding the exact same version of hydrogen. And atoms are not indivisible. We know now with fission and fusion that you can divide atoms, and it creates a huge nuclear explosion whenever you do. Okay, so we know that those 2 things are false. Something else that you'll find on your exam will be, if we go down to question number 8, in Rutherford's gold foil experiment, what happened to the alpha particles when they hit the gold foil? And these 2 are kind of together. So let's look at what happened in the Rutherford gold thing. Okay, essentially what that was just laser, and this is gold foil, was just a laser being aimed at something at the gold foil, but then this is what kind of received it. So essentially, we see that the laser passed right through the gold, right? We see like if we're shooting a laser through this, this is the gold. We're missing the gold most of the time. And then every now and then we get this hit and then we get these deflections. So it's like you're aiming something, you miss some, sometimes you hit something, and then that's what caused it to go somewhere else, to ricochet off the walls. And really what was important about this was that it just proved that it's mostly just empty space. When you shoot through an atom, you're mostly just hitting empty space. Every now and then you'll hit the nucleus, which will cause that deflection, that movement. Um, but it's really just empty space overall. That's kind of the point that was trying to tell you. Okay. We're almost done with page 1 of the practice test, so we'll move on. All right. The next thing that you guys need to know is uh, number 10. What is wrong with the Bohr model of an atom? Okay, so let's look at the notes again, and let's look at the Bohr model. He developed more in which electrons are restricted to specific energies. So it shows this where the electrons are following this planetary-like orbit. However, electrons do not have neat orbits like the planet. Okay, so for this one, you should have put what is wrong with the Bohr model of an atom is that it really doesn't follow this nice planetary orbit. That's fake. That's a lie. That's not how it works. Okay. So that would be number 10. All right. We're going to flip over to page number 2. Okay. The next one that's important is describe the quantum mechanical model of the atom. What I want you guys to do for this is read this part. Just literally just brush up on this. This is the current model. It's a mathematical model. This is the best idea we have right now. We don't know exactly where electrons rest, like in this one, but we know that they're in specific regions, and we cannot predict exactly where. We can say it's likely that it's somewhere, but not exactly where. So make sure you read up on this really quick. All right. Question number 13. Why is an atom neutral? Well, if we look at what an atom consists of, we've got protons, neutrons, and electrons. Where this is positive, this is neutral. It doesn't have a charge, and this is negative. We've done 8 before, right, where atomic is equal to proton is equal to electron, and the protons are equal to the electrons because, well, if you have 8 protons, these are positive, it makes sense to have -8 to balance out. So that's essentially why the atom is neutral. Overall, +8 -8 is 0 charge. All right. Question number 14, define an isotope. Isotope, we've done it so many times already, right? But it is essentially the same exact, let's do for lithium. Lithium-6, lithium-7. It's the exact same element. If we're looking at the periodic table, lithium is all the way to the left. Lithium on the periodic table, atomic number 3. So I know that lithium has 3 protons. This is lithium-6. This one is still 3 protons, lithium-7. Okay. This is an isotope. These are isotopes. So an isotope, if I'm just looking at it, I can say same protons, same amount of protons, different number of neutrons. This one is 7 minus 3 has 4 neutrons. Or, sorry, see, I flipped this. This should have been the opposite way. Where it's lithium, the 7 should be on top and the 3. And then 7 minus 3 is 4, 6 minus 3 is 3 neutrons. Same element, different number of neutrons. You guys should be really, really used to that by now. This is not the only time we're going to be using it during the semester. All right. All right. Question number 15 we'll skip. 16, you'll have to do something similar to this on the test. Notice that it says phosphorus 31. That's one of those ways that we talked about, that you'll see it, right? Where the 31 is the mass. Here, when it comes to this problem and it gives you the mass, don't look for the mass on your periodic table, okay? Forget that. If I'm telling you the mass that I want you to use, which is 31, stick to that mass. I'm going to do these first two rows, okay? So for phosphorus 31, I want to find phosphorus on the periodic table. I already know that phosphorus is right here, and it's 15 is the proton number. 30.9, again, I'm going to go off what this says. So the isotope symbol is just, what's the element symbol? P for phosphorus. I already told you the mass is 31, so that would be the isotopic symbol. The mass, well, I just told you it's 31. The atomic number, that's when you use the periodic table and you figure out that the atomic number is right there, it's 15. Neutrons, well, if your mass is 31 and your neutrons or your protons, your atomic number is 31, you just do 31 minus 15, and that's going to be 16 neutrons. Remember, you can do man. So mass minus atomic is equal to neutron. And if you forget that before the test, ape man, you can go back to that and look at it. Okay? And then electrons, right? Well, if we have ape, that's atomic is equal to proton equal to electron. If we have 15 protons, we're going to have 15 electrons. Okay? So that's how you do that. And I'll do one more of this because it's that important that you guys know how to do this stuff. All right, let's work backwards. So we know that the mass is 40. The atomic number is 18. I wonder what element that could be. If I'm looking at mass, multiple elements have a mass close to 40, so that won't tell me anything. There's only one element, though, that has an atomic number of 18, and that is argon. See this one, 39, that's close to 40. This one has 40, so that's the mass is never a good indicator of what atom it is. So we're going to go off the atomic number, so it's 18. We know that this is Ar. Okay, what's the isotope? Well, we're just going to call it argon. We already know the mass is, 40. The symbol would just be the same exact thing, but now we say Ar 40. We just follow, again, ape, man, where we have atomic is 18, which means proton is 18, which means electron is 18. And then neutron, our mass was given 40 minus our atomic 18. 40 minus 18 is 22 neutrons. Okay, and that's it. That's pretty much page 2. We're going to do one more on here, and then we'll move on to page 3, which is the last page. All right, guys. All right. So this, right? Once you know how to do this, and this is the only time we'll use it in the entire year, but once you know how to do it, you are set. A lot of you got mixed up with this homework, for example, or a lot of you maybe just copied off somebody else. I wouldn't suggest doing that because a lot of people got this particular question wrong. Okay. One way, before you even touch this, one way to figure out what your answer is going to be is, when I was grading this, a lot of people put, okay, when they added all the numbers up at the end, they got 40 point whatever. Let's say 1. None of these numbers are 40, and you're taking an average. So why would you even get 40 as an answer choice, right? Y'all did the math wrong. You should have any number that's between 35.97 and 39.96 probably is correct. Not necessarily, but it's probably correct. So how I do these, and you're going to have to do them the same way, I1, I2, the good thing is, once you get down the process, it's the same thing for every single thing, every single one of this. Okay, so notice your mass is, okay, let's start with the first one, 35.97 multiplied by, and right here, everybody, or a lot of people messed up. They did, okay, I'm going to multiply that by 0.337. Percent. You cannot multiply by a percentage. You have to turn this into a decimal by adding 2 zeros in front, moving it twice to the left. So that's 0.00337 equals whatever it equals. I2, 37.96 multiplied by 0.063. You have to add those 2 zeros again. 0.00063 equals whatever that gives me. And then now 39.96 multiplied by, move the decimal place 2 places to the left, 0.996, whatever that equals. All right, now I1, I2, let's figure out what it equals. Okay, now remember, you are multiplying, so you're going to have to follow the rule of sig figs. In this case, they all have 4 significant figures. These percentages don't count as significant figures, so we're not worried about that. We know that we have to keep to 4 sig figs. So I'm going to take my calculator. All right, I'm going to do, why does this go away? All right, I'm going to do the first one. So let's do 35.97 multiplied by 0.00337. And that's going to give my, let's hit execute. Oh, sorry, I forgot to multiply. So we have 35.97 multiplied by 0.00337 equals 12.21. I stopped there because if this has 4 sig figures, this answer has to have 4 sig figures. And again, I did a mistake. 12 is too high a number. I should have put a decimal, so I'm sorry about that. 3.597 multiplied by 0.00337. If you caught it before I did, good job. Okay, so that'll be the decimal will be right there. And I will erase that. All right, so let's move on. Okay, second one. We have 37.96 multiplied by 0.00063 gives me 0.0239. These are not 4 significant figures because that leading 0 does not count. So that's 1, 2, 3 significant figures, and that 1 is going to be my next one. That 4 doesn't affect the 1, so I don't have to round up. So I'll stop there. And then my last one, which is 39.96 multiplied by 0.996 is going to give me 39.80016. I need 4 sig figs, so that's 1, 2, 3, 4. This doesn't matter, doesn't affect it, doesn't affect the rounding, so I'll stop right there. All I have to do now is just add it up. So let's add it up. 39 point, let's start this again, okay? 39.8 plus 0.1221 plus 0.02391 gives me, let's bit, gives me 39.94. That 6 affects that 4. It makes it round up. So I would have to put not 4, but 5 AMU. Don't forget the units, right? So that is one entire process, okay? A lot of you would forget the AMU, or you forget to round, or you forget to do the 4 sig figs, or you would forget to do the decimal percentage right. It is a lot of steps, but it is relatively easy if you do enough. Like I said before, how can I double check this is right? Is 39.95 biggest, bigger than my biggest number? No, it's right below. Is it too low? No, it's in between these three numbers, so I'm fine. I know that I did this whole thing probably right, unless I messed up at any of the points that we talked about. So a lot of room for error here, guys. If you're not taking it seriously and not watching out for those sig figs, you're going to get the answer wrong. And again, it's not just that this unit, this is the only time you'll see those sig fig stuff. We're going to be hitting this every single unit. So there's really no escape from it. If you're not understanding it, then you're just not going to be getting those questions right throughout the year. All right. All right, so we're moving on to the last page now here. Okay, and I'm going to go ahead and skip those. I'm skipping them not because you don't have to know it, but because I'm just leaving it for your own. I'm going through what I think people need help with the most, okay? So let's go over 24. Okay, these questions are actually, I think, pretty easy as long as you know what alpha does and what beta does. Alpha, every single time, is going to release a helium atom with a mass of 4 and an atomic number of 2. Beta will always take a neutron, turn it into a proton, which makes the atomic number increase by +1. So if this is 80, now it's 81. All right, so that's that. So let's solve one for each. So if we're solving an alpha, right, we know that this is 96 MO and the atomic number is 42. We know that the two daughters it's going to have is going to be a helium, He2, and then we're trying to figure out what that element is that we don't know, but, right, we know that this has to add up to 42. So 2 plus what is 42? That's easy. So 40 plus 2 gives me that. Done. And then what plus what gives me 96. So 4 plus what gives me 96. That's just a simple math. 92 plus 4 is 96. All that's left now is what element has 40? Just go look it up. Element 40 on the periodic table, ZR. Okay, I'm done. ZR. Okay. Is there a faster way to do this? Yeah. If it's alpha, right, and when I tell you it's element 42, it's always going to be 2 elements down. So 1, 2, ZR. If I would have given you, let's say, Li, which is atomic number 3, you would know that Li, 2 doors down, boom, boom, the answer would be hydrogen. So again, this is why they're so easy. Once you know what they do, it's really, really easy to figure the rest out. All right, that brings us to beta. Beta has its own trick, right? If your atomic number is 80, you just move 1 up. So 238, 92. You know that 92 is going to turn to 93. And 93, so 93 is NP. You're done. All you have to do is make sure that you got NP 93 and a neutron turning into a proton. They both weigh 1, so your mass stays the exact same. If this has a mass of 238, your mass stays the same. All right, guys, we got 2 more, and then we're done with all of this. All right. Um, 25. What is meant by background radiation? Are background radiation sources natural or man-made? List some examples of background radiation. The answer is really they're both. Um, it's a little bit of everything. Background radiation happens from the sun. It happens from food we eat. It happens from man-made carbon that we're releasing into the air. It's happening everywhere. Every single day we're exposed to background radiation. Okay. Um, so that'll be that. Describe fission and fusion. Which nuclear power plants use? The sun. Okay. So fission. When you see fission, think division. And when you see fusion, I like to think of it as Dragon Ball Z, right? Two things coming together, forming that, and then division, right? Two things separating apart. That's how I remember it. Fission, if we're asking the question, which do nuclear power plants use? We use division. We use something, right, to cause this split. This split releases a giant explosion, and we use that energy. Okay. Um, the sun uses fusion because think about the sun and how much energy there is. It takes a lot of energy to bring two things like this together, and the sun is one of the best things that has that amount of energy. Very few things have that much energy where they can just fuse things together. All right. So really, for the test, you have to know fission is dividing, fusion is coming together. All right. That is it for this. Good luck on your test, and see y'all next time.